Can you imagine a world where your electric vehicle would never need a battery replacement and your smartphones would charge without losing their peak performance? Sounds like science fiction? Well, it is not. Because the innovation of zinc batteries in Germany is all set to break the barriers and reshape the world. Yes, you heard it right, because zinc batteries last not just for years, but decades, without ever losing their power. These batteries aren't just competing with lithium-ion, they're leading a quiet revolution that could redefine energy storage forever. But how is this transformation actually happening? Let's dive into the incredible story of zinc batteries and discover why they might be the future of power. Zinc might not be as famous as lithium, but it has some amazing qualities that make it a great choice for advanced batteries. First, zinc is everywhere. It's the 23rd most common element in the Earth's crust, meaning we have plenty of it. Lithium, on the other hand, comes from a few specific places worldwide, making it harder and more expensive to get. This abundance of zinc makes it cheaper and less likely to run into supply problems. But that's not all. Zinc batteries are also much safer and better for the environment. Zinc batteries often use water-based solutions, which are not only non-toxic but also eliminate the danger of catching fire. This makes zinc batteries a safer option for many applications, from storing energy on the grid to powering everyday devices. With all these affordable, safe, and eco-friendly benefits, zinc batteries sound like the perfect solution. So, don't you wonder why they are not everywhere yet? The answer is that zinc batteries face a few big challenges that have slowed down their progress. These challenges are what researchers are working hard to solve. Before we continue to highlight the challenges faced by zinc batteries, don't forget to press the subscribe button along with that bell icon so that you won't miss any exciting updates. Although zinc batteries have a lot of potential, they also have to face three big problems, which include dendrites, corrosion, and the hydrogen evolution reaction. These issues make the batteries less reliable and limit how long they can last. Let's break them down in simple terms. First in the list, we have dendrites. Dendrites are tiny, needle-like structures that grow on the zinc part of the battery when it charges. Imagine little spiky branches that keep getting bigger. Eventually, they drive through the battery's separator, a thin layer that keeps parts of the battery from touching. When that happens, the battery can short circuit, stop working, or even become unsafe. Secondly, corrosion happens when zinc reacts with water in the battery's liquid solution called the electrolyte. This creates a material known as zinc hydroxide, which clogs up the battery like junk, blocking a pipe. You may take it as a fancy hotel filling its rooms with unwanted guests, but there's less and less room for the real guests, the zinc ions that store energy, so the battery can't work as well. Lastly, it's the hydrogen evolution reaction, which is like a gas leak in that same fancy hotel. This reaction makes hydrogen gas during battery operation. It damages the battery and disrupts how smoothly the energy flows. Over time, it ruins the battery's ability to store and deliver power efficiently. Because of these problems, zinc batteries haven't been able to last long enough for many uses. But the good news? Scientists are making big breakthroughs to fix these issues, bringing us closer to a future where zinc batteries can really shine. Scientists at the Technical University of Munich have made an incredible breakthrough. They've created a zinc-ion battery that can last an unbelievable 100,000 cycles. It is a battery that's supposed to be so strong and durable that it could work for decades without breaking down. The secret? Let's have a look. The key to this innovation is a special protective layer for the zinc anodes of the batteries. This layer addresses previous issues such as the growth of needle-like zinc structures, known as zinc dendrites, as well as unwanted chemical side reactions that trigger hydrogen formation and corrosion. The research team, led by Prof. Roland A. Fisher, Chair of Inorganic and Metal Organic Chemistry at the TUM School of Natural Sciences, uses a unique material for this purpose. a porous organic polymer called TPBD2FF. This material forms a stable, ultra-thin, and highly ordered film on the zinc anode, allowing zinc ions to flow efficiently through nanochannels while keeping water away from the anode. TPBD2F is a 2D porous organic polymer that does more than just protect the zinc part of the battery, called the anode. It actually changes the way batteries work. This material has a crystal-like structure that works like a smooth highway for zinc ions. Instead of creating messy clumps called dendrites, it allows the ions travel freely. And what's even more amazing is that TPBD2F is zinc-philic, which means it attracts zinc, and hydrophobic, meaning it repels water. These two properties stop the problems that usually harm zinc batteries: dendrites, corrosion, and even the hydrogen evolution reaction. In simple terms, TPBD2F creates the perfect conditions for a zinc battery to work smoothly and last a very long time. Thanks to this innovation, zinc batteries now have the potential to be not just longer lasting, but also more reliable than ever before. The future of zinc batteries is incredibly exciting, but they may not replace lithium-ion batteries in electric cars or smartphones just yet. One reason is energy density. Zinc batteries can't hold as much energy in a small space as lithium-ion batteries, which makes them larger and heavier. For example, if your phone runs on a zinc battery, you might need a big carrying case just for the battery. However, zinc batteries are very safe and durable, which makes them better suited for larger, non-moving uses like storing electricity for power grids. Zinc batteries are already helping with renewable energy storage, such as solar and wind power. Companies like EOS Energy Enterprises are using zinc halide batteries to store this green energy. In California, EOS has expanded its facilities to store 60 megawatt of energy, supporting renewable energy projects. These batteries are also non-flammable and eco-friendly, which makes them a safe choice in places that deal with wildfires or other environmental risks. Zinc batteries also have the potential to improve energy grids and make them more reliable. Their long lifespan and safety make them a perfect backup for important places like hospitals, schools, and emergency services. In areas where power outages are common or dangerous, zinc batteries could be lifesavers by keeping the power running when it's needed most. Adelaide, PhD student and lead author of the research published in Advanced Energy Materials, explains, zinc-ion batteries with this new protective layer could replace lithium-ion batteries in large-scale energy storage applications, such as in combination with solar or wind power plants. They last longer, are safer, and zinc is both cheaper and more readily available than lithium. While lithium remains the first choice for mobile applications like electric vehicles and portable devices, its higher costs and environmental impact make it less attractive for large-scale energy storage. Prof. Roland A. Fisher adds, "This is truly a spectacular research result. We have shown that the chemical approach developed by Delay not only works, but is also controllable. As fundamental researchers, we are primarily interested in new scientific principles, and here we have discovered one. We have already developed a first prototype in the form of a button cell. I see no reason why our findings couldn't be translated into larger applications. Now, it's up to engineers to take up the idea and develop appropriate production processes. As the world starts to use more renewable energy, it's becoming really important to find ways to store energy sustainably. Zinc batteries are a great fit for this goal. While lithium, which is often used in current batteries, requires a lot of energy and resources to mine, zinc is much easier to find and recycle. It's also not tied to just a few countries the way lithium is, so it doesn't have the political problems that lithium mining can cause." In addition to their work with zinc, the researchers at the Technical University of Munich, TUM, have made another big discovery. The special material they've developed, called TPBD2F, doesn't just work with zinc. It can also improve other types of batteries, like those using sodium and aluminum. This means there are many exciting possibilities for using this breakthrough to make different kinds of batteries better and more efficient. And Even though the new zinc battery technology has shown a lot of promise, it's still in an early stage of development. The researchers at the Technical University of Munich have tested it in the lab, and it works well there, but it hasn't yet been used on a large scale, which means it's still not ready to be used by the public in everyday. This stage is called Technology Readiness Level 4, which is still far from the final product that you could see in stores or big projects. Now, one of the biggest challenges is making these batteries on a larger scale so they can be used in things like renewable energy storage systems. This is difficult, especially when using new materials like TPBDF2F, which are still being explored. But if researchers and companies can figure out how to make and test these batteries in a bigger way, zinc batteries could become a key part of storing renewable energy all around the world in the near future. Zinc batteries offer much more than just a way to store energy. They represent a big step towards creating a future that is better for the planet and stronger against challenges. The fact that these batteries could last for up to 100,000 charging cycles isn't just about technology. It's about reducing waste, saving money, and helping people trust clean energy solutions even more. As the world starts using more electric cars and renewable energy like wind and solar, the lasting power and safety of zinc batteries could completely change how we store and use energy. Imagine the batteries used in your home's solar energy system lasting just as long as the house itself, not needing to be replaced for many, many years. Imagine energy grids, which get power from wind and solar, running smoothly without breaking down, even when the weather is tough. Zinc batteries make these dreams possible, helping to power a cleaner, more reliable future, one step at a time. In conclusion, zinc batteries are more than just an alternative to lithium. In fact, they're a bold step into the future of energy storage. From their abundance and affordability to their incredible durability and safety, they're proving that innovation doesn't always mean reinventing the wheel. Sometimes it's about making the wheel work better, longer, and more sustainable. As we look toward a future powered by clean energy, zinc batteries are lighting the way with incredible potential. So, what do you think? Could these durable, safe, and eco-friendly batteries be the key to a greener tomorrow? Let us know in the comments below. Also, if you enjoyed this, don't forget to like, share, and subscribe for more exciting insights into the future of technology and sustainability.